Hi all and welcome to today's class. So this is the class for the 23rd of March and it's class number 69. We're going to continue with our look at factorisation, and in the last class you were looking at grouping. Now the third type of factorisation which we're looking at today, which is factorising quadratic trinomials, is going to build on what we've already done with grouping. So if you still haven't looked at that, or if you're still having issues with that, please try and work through those questions first before moving on to the quadratic trinomials, because I'll be using grouping in this video. So just some keywords for you to take down into your copies. So quadratic, we'll talk about that. We've touched on that a few times. We'll talk about exactly what that means. Trinomial, guide number is the method that we're going to use. Grouping, so that's going to come into it, just like in grouping how we used highest common factor. So these three types of factorisation all build on each other. We're going to be talking about factors, but also product, which is another word to say the multiplication, and sum, which is another way to say add. So if I said what's the product of two numbers, I'd be asking what answer do I get when I multiply them. If I asked you what was the sum of two numbers, the answer would be what happens when I add them. Before we move into the quadratic trinomials, I just want to review some grouping questions that cause a bit of problems. Now the straightforward ones that didn't need any rearranging, they worked quite well for most people. However, these harder questions, that last section, the last five, caused problem. And interestingly, it was actually the last four caused problems, because the first one there was nothing weird about signs. They were all positive. So this has really got to do with signs causing the problem. Now the good news is the grouping we're going to need for this video will be quite straightforward, so we more like the first section of homework you had from the last class, but I'm going to review these anyway just so we can see what's going on. So this came from the section where there was going to need to be some kind of rearrangement in order for us to have a highest common factor within a group. So the first step is always to double check, is there anything common to all terms? And unfortunately there's not. So what I'm going to do is I'm going to swap these two here. And when I swap those two, I get AC minus AD. So remember that sign goes with it. Now in this case they're both minus. And minus BD plus BC. So now we have our two groups and they do have something in common. So in the first group we have A, and that leaves me C minus D in a bracket. And in the second group, and I said, and this is going to be important for moving forward today, the general rule of thumb, so in the majority of cases, bringing down this sign from above, so that was a minus, so I'm going to put a minus here, that should be fine. I'll do that actually in a different colour. So we pull down that minus, okay? It may be wrong and we'll have to check it, but it'll work in the majority of cases. Oh, I had accidentally wrote CC, that should be BC. So we have a B common, and that leaves us with D minus C. So we've taken, now really watch your signs here, because if I am multiplying minus B by something to get BC, it would have to be a minus C. This point I check, are my brackets the same? And they're not. There's an issue with our signs, because the C in my first bracket is positive and the D is negative. That's the opposite way around, so our signs are incorrect. So what we're going to do is we're going to change this sign, which then changes this sign, and then changes this sign. And now the two brackets, although they're backwards, the D is negative and that C is positive. So we can combine this as A plus B, and we would generally write this as C minus D, because we generally, it's good practice to write the positive letter first, because the minus coming in front can often get lost. However, if you did write it minus D plus C, that would be absolutely correct. A plus B could be written in either order, so it might be B plus A, or so on. So really just keeping an eye on these signs. Let's do the next example. So again, there's nothing common. So I'm going to do a little bit of a switch. I'm going to switch again these two terms, and that gives us mx minus 2my plus 24by minus 12bx. So now we have our two groups, and we're going to do highest common factor on each group. So an m is common here, which leaves me with x minus 2y. The next one, it starts the plus, so I'm going to try this. Now, we saw in the last one, it may not always work, but we'll try it. Now, this has both a number, so 12 is common, and a letter, b is common. So that leaves us with 2y minus x. Now, here we look at our two brackets. Are our brackets the same? No, because in our first bracket, x is positive, 2y is negative. So I'm going to need to change my signs. So that's going to change to a minus, but then this will also change to a minus, and this will change to a plus. And as we do that change, the brackets now will be the same. So we get m minus 12b x minus 2y. So if you're saying, but is that not the same thing as 2y minus x? It's not. So really be careful. It's the same as 3 minus 2. Is that the same as 2 minus 3? And although the numbers are there, no, because in one case you're taking away that 3 is negative, the other case that 2 is negative. So they are not equal. Be so careful with that. So now let's look at x squared minus 2y minus 2x plus xy. So I'm going to swap these middle two terms because there's definitely nothing in common in all four terms. I've looked at the first two, there's nothing in common, so I'm going to have to rearrange it in order to do highest common factor on each group. So this is what I get. There are my new groups, and if it is easier, you can rewrite x squared as x, so you can see, oh yeah, there's an x common and it leaves an x. Because a lot of people are getting confused about x squared and 2x and getting the same kind of answer when you pull out an x. Just be so careful with that. And if you need to rewrite those indices as xx or xxx if it's x to the power 3, do that. So here we have, I'm going to pull out the minus, and a y is common, and I get 2 minus x, but that is not correct because the signs are wrong. So this will become a plus, this will become a minus, and this will become a plus. That means my brackets will then be x plus y and x minus 2. So the next one here is an interesting question because it was part of the section where I said you need to rearrange it. However, some of you may have gone, oh, well, why? Because actually there's a 3 common in this group and there's an a common in that group, so could I not just factorize as is? So let's see what would happen if we did that. So 3 is common, left with a squared minus bc, and I will pull out a minus a, and I'm left with b minus 9c. Okay, those brackets are not alike. They're not even close to being alike. It's not even like in the last one where we'll need to change our signs. They're not even close. So sometimes, although there may be something in common, when you do that, you're going to find that the brackets are just, yeah, they're not the same. So that is not the correct way to group them. So we're going to need to come up with a different way to group them. So I'm going to come up with swapping the middle terms. So minus AB minus 3BC plus 9AC, and we will group them like that and see if we get something different. So here, if you prefer, that's 3AA. So that means A is common, leaving us with the 3A minus B. And here I'm going to take that minus, and a 3 is common because it's 3 and 9, so 3 divides into both, and a C is common. So we're left with B and then a minus 3A. Now again, signs are looking not great, so I'm going to change that to a plus, change that to a minus, and change that to a plus. So we have A plus 3C bracket 3A minus B. Now, in every single one of those questions, the way that I've had to rearrange, I've had to change my signs. So I know there's some of you sitting there going, could I not just take the opposite to what that sign is, because then it'll have worked? And no, I am going to stick to what I'm saying about the rule of thumb is we follow whatever that sign of the third term is. And when we use grouping today, that rule of thumb will be valid for all quadratic trinomials. So although it doesn't work for all of our grouping questions, it will work for all of this section. So I think because quadratic trinomials are more common than our grouping questions, that I'm going to stick to that. So let's play a little game. I've put in a multiplication chart for you. You probably haven't, maybe you have seen one of these. Basically, it helps us to do any multiplication up to 10. It's basically your tables, in case you need reminding. We have the yellow and the white, and they're actually mirrored, because if you look at 3 times 4 is the same as 4 times 3. So the yellow and the white are pretty much mirrored. So you could focus just on the yellow part. The green numbers are special because the green numbers are our perfect squares. So they are something that we multiply a number by itself to get. So 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. So I'm going to ask a series of questions, and I want you to try, pause the video if you have to come up with the answer yourself, and then I will put up the answer. So this is all practice for what we need to be able to do today. So the question is, what two numbers multiply to 6 but add to 5? Okay, so if I go to, and I'll do this one quite slowly, how I'd use my multiplication chart. So basically I need to figure out, well, what ways can I multiply numbers to get 6? So looking at the multiplication chart, or in your head, you should know that the factor pairs of 6, and it really is about factor pairs. So to get 6, I could do 3 by 2, or I could do 1 by 6, and that's it. That's the only two options. That's what the table is telling us, showing us in red. But then I want to know, well, then also they have to add to 5. So the correct answer would then be 3 and 2, or 2 and 3, whichever way you want to think of it. So that's what we're looking today. So we first of all start with the multiplication piece. The multiplication piece is always the easiest place to start because there is a limited number of factor pairs, especially if it's prime, because prime means it only has one factor pair, itself and 1. And then we need to figure out what happens, or what one is valid for the number we wanted to add to. So what two numbers multiply to 6 and add to 7? 6 and 1. What two numbers multiply to 12 but then add to 7? So if we want to work 12, we'd make a list of all the factor pairs. 12 by 1, 6 by 2, 3 by 4. Now somebody might say, but what about 2 by 6? It really doesn't matter of order. Remember, multiplication is commutative, so it doesn't matter which order we put them in. So which one of those is correct? Well, 3 and 4 adds to 7, so the correct answer is 3 and 4. So what two numbers multiply to 12 and add to 8? So maybe at this point you're not using the table. You're kind of doing in your head 12, add to 8, what could it be? And the answer is 6 and 2. What two numbers multiply to 20 and add to 12? And it's 10 and 2. What two numbers multiply to 20 but add to 9? So a different factor pair. So you're thinking, well, 10 and 2, no. 20 by 1, no. The answer is 4 and 5. So now I'm making it a bit harder. I've also taken away our table. So let's see how you do at this one. What two numbers multiply to 48 and add to 19? So pause the video for a second, work out all the different factor pairs of 48, and then figure out which ones add to 19. And the answer is 16 and 3. Now, I think for this one, students might have been, oh, that was really hard. We don't know 16 times tables. No, we don't know 16 times tables. So we need to figure out a way in which we can work that. So I asked you for the numbers that multiply to give me 48. So the factor pairs of 48, but that add to give 19. So I'll work out what I would do here. So 48. Okay, so I need to work out a load of factor pairs. So easiest one to start with is 48 by 1. Okay, so that's definitely not right. And then, well, I could also do 2. So 24 by 2. That won't work. And then I'd see, well, does 3 divide 8? Because I don't know. Like, it doesn't, 48 may not be on my 3 times tables. So you can use your calculator or your head to do 48 divided by 3. And when you do that, it works out as 16 and 3. And oh, that's the correct one. Now you could keep going with your factor pairs. So you could see, well, does 4 divide in? And actually that is one of our tables. 12 by 4. And then 5, no, 5 doesn't divide in. And then I try 6, and does 6 divide in? And yeah, we get 8 times 6. And does 7 divide in? No. And the next number is 8. But I don't need to go to there because I've already got 8 times 6. So I've kind of done full circle. I like this kind of logical work through. I usually start at the something multiplied by 1, and then I try 2 and 3 and 4 and 5 and so on until I complete it, until I kind of meet in the middle. And that 8 by 6 is the meet in the middle. Because if I try to divide 48 by 7, so if you've got your calculator, 48 divided by 7, it gives me a fraction answer. It gives me 48 over 7. That's what it returns. So it's not a factor. Remember, a factor is a number that divides in evenly. So now, another challenge. What two numbers multiply to give you 45 and add to give you 18? Again, pause the video, give it a go. And the answer is 15 and 3. So you could use the same logic that we just used to do that. And this logic is going to be really important as we work through today's questions. Feel free to go through that game again and try it yourself and make a list or just look in your copies and try figure it out. This is going to be so important. So what are quadratics? So the name quadratic comes from the word quad, which sometimes students go for, but actually quad is more of the idea of the square. So it's because it's x squared. We might also hear it referred to as having degree 2 because 2 is the highest power. Up to now, we've really been focused on linear. So they are expressions or equations that draw a line. And we would say that they have degree 1 because it just has an x. But if I just have an x, it has a power of 1. We just too lazy to write that power of 1. So we have that idea of a degree as well. So when we look at quadratics graphically, so if we plotted them on our x and y axis, our Cartesian plane, we would end up with this lovely curved shape. So we'll do a lot more on the graphs of quadratics, but just for now, if you take this down, we have two types of quadratics that we see. We have a positive quadratic that looks like a lovely smiley face, and then a negative quadratic which looks like a frowny face. We'll do a lot more on what exactly that positive and negative means, but just a quick way to help you remember it: positive people smile, negative people frown. Now let's look at actually factorization, these quadratic trinomials. So I didn't really talk about the trinomial piece. Trinomial means there's 3 pieces. So T-R-I means 3. Think of triangle, 3 angles, tricycle, 3 wheels. That's for you might have had one as a child. So when we talk about quadratics, we have that x to the power of 2. And trinomial means there's 3 pieces. So you can have a quadratic, so with an x squared, that doesn't have 3 pieces, and we'll see those. And you might have a trinomial that maybe isn't quadratic, but we will specifically here be looking at quadratic trinomials. So this is an expression that's given in the form ax squared plus bx plus c, where a, b, and c are elements of z. So z, hopefully you remember, are integers. Now, that's for the moment. That will change as we move further through the course into Leaving Cert, but for the moment, we're only worried about a, b, and c being integers, positive and negative whole numbers. So it might be, for example, 2x squared plus 3x plus 4, something like that. So this is all being taken down into your copy. So you can watch it through and then pause it and then take it down. So you get a sense of it. So quadratic trinomial is a special case of grouping. So take this example. So I'm going to do some expanding, some multiplication. So hopefully we're all okay with how to multiply out 2 brackets. We haven't done that in a while at the start of the year, so we'll do a little bit of revision on it. We want to multiply every term in one bracket by every term of the other. So what we do is we split the bracket. So we split that first bracket into x multiplied by the second bracket plus 5 multiplied by the second bracket. Then we just multiply as normal. So we get x squared plus 2x plus 5x plus 10. That's just a multiplication. But we're not finished yet, because generally these questions are expand, which we've done, and simplify. So we want to make sure it's as simple as possible. So actually we have a 2x and a 5x that can be added together, which gives us a 7x plus 10. So what we're left with here is a quadratic trinomial, because it's quadratic because it has an x squared, and trinomial, it has 3 pieces. So we didn't end up with 4 terms, we ended up with 3 because we were able to simplify the answer. And this is a quadratic trinomial. So this was expanding. And remember at the very start we said that expanding is the opposite to factorization. So basically what we want to be able to do is start with that x squared plus 7x plus 10 and work backwards to get those 2 brackets. So that's our aim for today, to work backwards on these quadratic trinomials, start with those and work back to our brackets. So we're going to take an example, and we're actually going to use the example we just worked through. So we know what the answer is going to be, but we need to understand, well, how do we get there? Because it makes sense for us hopefully with the multiplication and the adding, but what's the opposite to that? So the first step we're going to do is we're going to find the guide number of the quadratic trinomial. Now, this is called the guide number method, and we will see that there are other ways. Well, there's like a shortcut, and I will show you eventually the shortcut, but for the moment we're going to stick to guide number. And we want to find the guide number. So if you think on the road, your guidelines are either side of the car to keep the car where it's meant to be. Our guide number is what's at the start and the end. So it's what's here and what's here. Now I have to be really careful because I don't want you to think the x squared is in it. It's not. It's this number here and plus 10. You might say, well, actually there's no number in front of the x squared. But there is. Remember, we're just too lazy to write it, but there's actually a 1 there. We don't generally write it, because if I have an x squared, I have 1x squared, so we don't write it. So what we're going to have is guide number. I write GN for short, and it's going to be 1 by 10, and watch your signs, it's plus 10, so my guide number is plus 10. And hopefully everyone's okay with that. And you might say, well, sure, it's just the last number, but we won't always have a 1 at that start of the expression. So we want to find the factors of the guide number that add to give you b. So now, what is b? What are they talking about? So I want to figure out what are the factors of 10. So what multiplies to give me 10 but adds to give me 7. So we're back to this game we had at the start. So what multiplies to give me 10? So let's make a little list of all of the factor pairs. So it could be 10 by 1. Or it could be 5 by 2, and actually that's it. That's all we have. So then we need to come along and say, well, which one of those 2 factor pairs adds to give you b? So b, remember, is that middle term. So which of them adds to give me plus 7? And the answer is 5 by 2. So that's the answer. This is back to why we were doing the game earlier. 5 by 2. So step 3 is we're going to rewrite the quadratic, replacing the above factors. So what we're trying to do here is we're trying to break down that middle term into 2 terms. Remember, if you need to go back, look over how we did the multiplication. We had 4 terms, we combined them into 3. So we want to split out that 7x. So what we end up with is x squared, and instead of 7x, I'm going to put plus 5x plus 2x. So I'm just splitting it out. And hopefully you haven't changed anything. So does 5x plus 2x equal 7x? Because I can't change anything. It's an expression. I can't just randomly change stuff. But I've just rewritten it. I've made it look a bit different. So are we good with that? Is 5x plus 2x equal 7x? Yeah, so that's good. So that's step 3. And now we have 4 terms, so we can factorize. There's some good news on this factorization. It is grouping, which we've already done, and we will never have to rearrange. we will be able to take the groups exactly as they are. So x squared, if it helps, it's xx. So that gives me x is common times x plus 5. Here, there's 2 is common, and we're left with x plus 5. I double check that my brackets are the same. They are. So that gives me x plus 5 times x plus 2. Order doesn't matter on those brackets. And yeah, we're back to where we started with our multiplication. So this is called guide number method. So it is a direct opposite to our expanding. So step by step. So we just need to remember, and the key is the remembering of the guide number, what it is, and then how do we pick the right factor pair. So how do we know 5 and 2 were the right factor pair? It's because they added up to give me 7. So following the same steps, let's try another example. So we have x squared plus 3x plus 2. So my guide number is the first number multiplied by the last number, which is just going to be plus 2. I want the factors of 2, which is super easy because 2 is actually prime. So it's only 2 by 1. Once it's prime, life is very easy because that means there's only one way we can replace the middle term. Just double check anyway to make sure you've done it right. Does 2 and 1 add up to give us 3? And it does. So now we're going to basically break that 3x into 2x and 1x. And at this point, and again, you might be saying, oh, sure, look, it is, it's fine. But I really would love you guys to double check every time we get to this line, 2x plus 1x, does that give me 3x? Because when the signs start changing and it gets a bit more complicated, the things that go wrong is that those two numbers don't add up properly. So really just double check. So we are good. So all that adds up. So let's put into our two groups. X squared is x times x, and we get x bracket x plus 2 plus, and this time the sign will always match that third one, always. Plus, oh, there's nothing in common. So this sometimes happens with quadratics, and we didn't see it with the grouping from the previous class, but sometimes happen. We're left, and I'm going, oh, there's actually nothing in common. Now, I did say we will never, ever, 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 ever have to rearrange when we're doing our quadratic trinomials. If you've done it right, it should just work. So I don't need to rearrange, but there's nothing in common. But actually, there's always something in common. 1 will always divide in. So if you're left with a case going, oh, there's nothing in common, actually that just means there's a 1 in common. And that leaves me with x plus 2. Double check, are your brackets the same? They are. X plus 2, that bracket is common, and we get x plus 1, and that's our answer. So these quadratic trinomials, super easy. When you get into the swing of them, there's nothing terribly difficult until I start changing the signs. So now we need to be really, really, really careful about our signs. The method is not going to change. So first thing I'm going to do is I'm going to set up my guide number. My guide number is the first number, which is 1 by plus 6, so my guide number is plus 6. Don't get complacent, because tomorrow we will have numbers in front of those x squareds. So really think of the guide number as the first by the last. Now, we want to find our factors of 6. So you do 6 by 1 and 3 by 2, and that's it. But no matter what way you add that, 6 and 1 is 7 and 3 and 2 is 5. I don't want either of those. I actually want a minus 5. So we have an extra layer of complication. Now, when we have a plus here, basically two numbers that multiply to give me a plus 6. So what that's actually telling us, that the signs are the same. So they are like signs, because all of these 6 by 1 and 3 by 2 is valid, but also minus 6 by minus 1 will also give me 6. And minus 3 by minus 2 will also give me plus 6. So think about your multiplication. So we didn't take into account the possible negative answers in the last question because we didn't have to. But now, because we want to add to minus 5, we know that the signs are going to have to be minus. So actually, we're going to have minus 3 by minus 2. So let's break down that middle term into minus 3x minus 2x plus 6. And I'm going to double check. Do they add to give me the same? Oh, and they do. So then that is x times x to help with our grouping. And we get x is common, x minus 3. Now here's some nice minuses happening, and you'll see what I mean about taking the sign of the third term. So the next sign I have is a minus, and 2 is common, and that leaves me with x minus 3. No change of signs, the brackets just work. It's perfect. And then we have x minus 3 in the bracket, and x minus 2 in the bracket. At this point, I'll mention, because I don't think I've mentioned it, it doesn't matter what order you write the minus 5x or you break the minus 5x into. So if you had, and I'm going to do it over here, if you had written as x squared minus 2x minus 3x plus 6, would you have got the same answer? And yeah, of course, because you would have got x minus 2 here, minus 3 is common, and x minus 2 here, and you would have had x minus 2, x minus 3. So your brackets might be in a different order, but actually, final answer, absolutely perfect. So it doesn't matter if you do 3 by 2 and I do 2 by 3, the brackets should end up the exact same. Your step in the middle, that grouping might look a bit different, but our final answer should be the same. Now, I'm adding in an extra term, so make sure you are fully happy with the previous 3 examples. This is our last example for today. And again, all I'm doing is making it more difficult with the signs. So it's the numbers are more difficult. It's the idea of the factors and the sum is becoming more difficult. But the steps for factorizing haven't changed. Step 1, get my guide number. Now, what's your sign here? Because my first number is 1, my second number is minus 3. So my guide number is minus 3. So I need to understand the factor pairs that give me 3. Now, 3 is a prime number. So we say, woo, it's great. It's just 3 by 1. But actually, 3 by 1 won't give me minus 3. I could do minus 3 by 1. Or you could do 3 by minus 1. And they will both give me minus 3. So we have this minus here, and what the minus tells us, just like the plus meant that we had the same signs, these mean we have different signs. And we need to figure out which one will add to give me plus 2x. So here, if I was doing it, that would be minus 3 plus 1 would equal minus 2. Here will be 3 minus 1 equals 2. So the correct one is 3 multiplied by minus 1. So this is where it gets a bit more challenging. So we get x squared plus 3x minus 1x. You don't even have to put the 1 there if you don't want to. It just could be minus x minus 3. Now this is where it's so important to double check. Does plus 3x minus 1x give me 2x? Yeah. Taking that second to check, and this is something I tell the girls even up to 6th year, taking that second to check makes all the difference, and especially if it's going to make it harder to follow on a question. Like if this is just it, that's fine, but really do that double check. Get into the habit of it now. We're now going to do our grouping as is. You might have minus x and plus 3x, but that's fine. I'm going to use xx here just for help. And we get x bracket x plus 3. Follow the sign, so get minus, nothing in common, but we know a 1 is always in common. X plus 3, so minus 3 divided by minus 1 is plus 3. X plus 3 times x minus 1. And that's our final answer. So there's a little bit of thinking got to do with the sign. So if everything is positive, you are good to go. If there is a minus in there, so if the middle term is minus, if the last term is minus, you'll need to do a little bit of thinking. So homework for tomorrow, you're going to work off these questions here. I'm going to upload them as an assignment with the link attached for a form, as we have been doing, so I can see how you get on with them. I'll go through them all tomorrow anyway. The first four here are all positives, no issues with signs, very straightforward. I then have a mix of different signs here to see how you get on, and really take your time with those signs and make sure you're writing it all out, and see how you get on with them. Any questions, you can message me on Teams.